Hello and welcome to today's math lesson. So first of all, guys, can we all turn to wave and say a big hello to our friends on camera? Hello. Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hands on our laps, and close our eyes. And when you're ready, guys, you can open your eyes and come back to the room. And next we'll do our stretch sequence. So let's stand up and push in our chairs. And we can begin by stretching up high to the sky. High as we can. And then let's go down low and touch our toes. And now back up high one more time. And this time, can we go tippy-toe high? And while we're there, let's have a wave. And then back down to touch our toes once more. And now stand up. And let's have a little shake, guys. Arms and legs, shake it out. Shake it out. And now hands on hips, and we'll do a wiggle side to side. Stop. And then another wiggle side to side. Stop. Forwards, backwards, forwards, backwards, forwards, backwards, and stop. And now we'll go round and round. Give our spines a nice stretch, round and round. And stop. Now we'll go back the other way, round and round the other way. And stop. And to finish, we will do 5 claps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. So who can remember what we learnt about in the previous math lesson? Any ideas, guys? Mixed numbers is correct. Very well remembered. So let's write that phrase on the board again, guys. Mixed is M-I-X-E-D. And then numbers, N-U-M-B-E-R-S. Altogether, mixed numbers. Yes, and when we're talking about fractions, a mixed number is a proper number, a whole, such as 2, and then followed by a fraction, such as 1/2, or 1/2. Now remember guys, with mixed numbers, the fraction involved can only ever be a proper fraction, where the numerator is smaller than the denominator. Mixed numbers will never have improper fractions. So what mixed number do we have here, guys? 2, 1 over 2, or we can say 2.5. So to demonstrate this visually, what we need first, 1, 2, for our whole number. So we know if it's whole, all of our circle will be coloured in, because these are 2 whole circles. Now what do we need next? We need one more circle. But who can tell me what portion of our third circle needs colouring in? 1. Yes. What we need to do first is divide our circles into parts. We can even do with our whole ones. And then we have the denominator 2, so 2 parts, and the numerator 1. So we colour in 1 part of 2. So this is how we do mixed numbers and demonstrate them visually with circles. And what we're going to do now as a recap exercise is I'm going to write some mixed numbers on the board and then invite some students to come forward and demonstrate their understanding of how to visually demonstrate mixed numbers. So first of all, guys, let's close our eyes and I will clean the board. Okay, so that's a good mixed number to start with. And the pen is with Pak Bung. So Pak Bung, come and join me at the front of class, please. So all together, guys, what mixed number do we have now? 1 and 3 over 4. Or we can say 1 and 3/4. So first of all, we have our whole number, 1. So Pak Bung, what do we need to do? Correct. 1 circle. Now how much of this circle needs colouring in? No, all. This is the whole number. So all of the whole number needs colouring in blue. So you can colour the entire circle in because this is our whole number 1. Then what comes next? We need another circle. So we can draw another circle. So Pak Bung will now demonstrate the 4 different parts of the circle by dividing it into 4. Excellent, Pak Bung, you see. So we have our denominator as 4. But how many parts of this circle need colouring in blue, guys? 3, yes. So Pak Bung, you can demonstrate. 1, 2, 3. Perfect. That's our mixed number. You see, we have 1 and 3 over 4, or 1 and 3/4, because 4 of something is quarters. Pak Bung, that was brilliant. Very well done. High five. Big round of applause for Pak Bung, guys. Okay, let's do another one. But first I need to clean the board. Okay, let's see who can do this mixed number. And now the pen is with Bang Bon. So Bang Bon, come and join me at the front of class. So first of all, guys, let's read our mixed number. 3 and 1 over 3, or 3 and 1/3. Now what's our whole number, guys? 3. So how many circles do we need? 3 circles. 1, 2, 3. Excellent, Bang Bon. And how many parts of these circles need colouring in blue? All of them, correct. So Bang Bon, you can quickly colour everything in blue. Very good. That's 1, 2, 3. Perfect. We've got our whole number 3. 1, 2, 3. But how about our fourth circle? We can draw another circle, circle number 4 here. Now let's look at our denominator. How many parts? 3. So now we need to divide into 3 parts. Excellent, bang on. And then one more line there. Yes, that's correct. Okay, so now we've got 3 parts. But how many parts need colouring in blue? 1. That's excellent. You see, we've got the denominator 1, 2, 3, but the numerator of 1. So we can say, guys, 3 and 1 over 3. Or 3 and 1/3. Can you say bang on? 3 and 1/3. That's brilliant. Very well done. High five and big round of applause for bang on, guys. Let's do one more together and then we can move on. But first, I need to clean the board. And now the pen is with Nadia. So Nadia, come and join me at the front of class, please. So first thing we'll do, guys, let's read our mixed number. What's our whole number? 2.
3/5.
Yes, or 2 and 3/5. So first of all, our proper number, how many circles? 2. Correct, Nadia. So you can draw 2 circles. 1, 2. Now, as we know by now, these are the whole circles, so they all need to be coloured blue. So you can colour everything in blue, Nadia. 1, 2. Okay, very nice. Now for our third circle. Now let's look at our denominator. How many parts? 5. So Nadia, 5 parts, please. 3, 4, 5. That's excellent. Very well done. And how many is our numerator? 3. So how many parts need colouring in blue? 3. 1, 2, 3. And this is how we do our mixed numbers. So all together, guys, 2 and 3 over 5. Or 2 and 3/5. Nadia, that was excellent. High five and a big round of applause for Nadia, please, guys. So that was a recap of the previous lesson, mixed numbers, a whole number and a proper fraction. We're going to stay with fractions now. We're going to move on to look at something called, ready guys, equivalent. Equivalent fractions. Yes, so let me write that phrase on the board first. E, Q, U, I, V, A, L, E, N, T. Equivalent. Now, does anybody know what the word equivalent means? Any guesses? Equivalent. It's a strange word, and I'll tell you what it means. Same amount. Okay, for example, if I have 2 circles here, now let's say the first circle, how many parts? 2 parts. So that's our denominator. Now if I colour 1 part in blue, what's our numerator? 1. Okay, well how about for our second circle we have 4 parts. And now I colour in 2 parts. What do you notice? The circles are the same. 1 over 2 is the same as 2 over 4. Yes, because 1 is half of 2 and 2 is half of 4. So this is what we mean equivalent fractions. Even though we're using different numbers, it's the same amount. Each time, it's 1/2 of the circle. So what we're going to do now is take a look at a PowerPoint presentation for our students to observe, listen, and also practice speaking about understanding more about equivalent fractions. So let's turn to look at the TV screen, please, guys. So let's take a look at our PowerPoint presentation about equivalent fractions. Yes. In fact, let's take a look at our chart here. You see, the top line is in green. 2 halves. You see? 1/2 and 1/2. But then, if we look at the yellow line, there are 3 parts. 1/3, 3 times. But the reality is, both of these fractions are the same amount. They cover the same amount of bar. They are just written differently and divided into different parts. And this is equivalent fractions. A fraction is a number that represents part of a whole. Yes, a fraction is always a part of a whole. This fraction represents 1/2, or 1/2. Because we can see here, how many different parts are there? 2. But how many parts in green? 1. 1/2 of the circle is in green. This fraction represents 2/4, or 2/4. Yes, because how many different parts to the circle, guys? 4. How many parts in green? 2, yes. 2/4. This fraction represents 4/8, or 4/8. Because how many parts to the circle are there?
8.
How many in green? 4. Yes. So 1/2, 2/4, 4/8. All of these fractions represent the same amount. 1/2 of the circle. You see, when we look at all 3 circles, the same amount is in green. 1/2, 2/4, or 4/8. And when we talk about the same amount with different fractions, that's what we mean by equivalent, because they all represent the same amount. 1/2, 1 is half of 2. 1 times 2 equals 2. 2/4, 2 is half of 4. 2 times 2 equals 4. You see, it's half every time. 4/8. 4 is half of 8. 2 times 4 equals 8. So you see, each time the fraction is half of the whole. And this is what we mean by equivalent fractions. Same amount equals equivalent fraction. You can see it's the same amount of green in every circle. They're just divided up into different parts to represent different fractions. Any questions, guys? Okay, that was brilliant. Well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation about equivalent fractions and how they basically mean the same amount, just divided into different parts. For example, 1/2, 1/2, is the same as 2/4, 2/4. They're just represented differently, but are equivalent amounts. And we've got a flashcard exercise coming up soon for our students to demonstrate their understanding. But first of all, guys, time for our stretch sequence. So let's stand up and push in our chairs. And for this sequence, we'll begin with some rotations. Left, right, left, right, left, right, left, right, left, right. Excellent, guys. Now what we'll do is we'll do 5 stretches to our right. 1, 2, 3, 4, 5. Excellent. And now we'll do 5 stretches to our left. 1, 2, 3, 4, 5. Brilliant, guys. And let's have a shake. Arms and legs, shake it out a bit. Shake it out. And then to finish, we will take our right hand and touch our left foot. Left hand, right foot. Right hand, left foot. Left hand, right foot. Right hand, left foot. Left hand, right foot. And to finish this one, we will do 5 star jumps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. So now it's time for our flashcards exercise. So teachers, what you'll need to do is print out the flashcards for your students, cut them into individual fractions and place them into a bowl. And what we're going to do is have students come forward, choose a flashcard, and then write an equivalent fraction to the flashcard they have chosen. Well, first of all, let's do the title. So equivalent. E, Q, U, I, V. A-L-E-N-T, equivalent. So that's quite a fancy word, but just remember, equivalent means same amount. And then fractions, F-R-A-C-T-I-O-N-S. So altogether, guys, equivalent fractions. Okay, and now I need my flashcards, which are here. And now I need my first student. So I would like to invite Net. Come and join me at the front of class, please, Net. Choose a flashcard and show it to your friends. 1/2, or 1/2. So, okay, first of all, I will draw that fraction. And let me draw it in blue. So 1/2. How many parts do we need? 1. We need 2 parts. Remember, the denominator, 2 parts, but how many parts in blue? 1. Okay, so we've got 1/2. Now I will give the marker to Net. And Net will demonstrate how to draw an equivalent fraction on the board. Okay, excellent, Net. So what we've got now, we've got our circle. How about if Net divides his circle into 4 parts? So Net, into 4 parts, please. Brilliant. So first of all, we can write our denominator 4. Okay, and then our line. So 1 is half of 2. What is half of 4? 2. Well done, Nadia. So how many parts need colouring in blue? 2, correct. So net, we need 2 parts in blue. Excellent. And then we write our numerator 2. So look guys, 1/2 of the circle is in blue. 2/4 of the circle is in blue. It's the same amount. And this is what we mean by equivalent fractions. So net, one final time, 1/2, 2/4, equivalent fractions. That was brilliant, Net. High five and a big round of applause for Net, please, guys. Okay, so teachers, you can see the activity that we're doing in our classroom now. You can pause the video and play on with your own class. And remember to choose a different student each time and have the entire class practicing speaking. And play on for around the next 12 minutes or so, and then come back for the worksheet activity. And we're going to carry on playing in our class now. But first of all, I need to clean the board. Okay, so now it's time for our next student. And I would like to invite Lakau. Come and join me at the front of class, please. And choose your flashcard. And show it to your friends. 2/4. Okay, so first of all, let me draw that fraction on the board. So we need our circle. Four parts is our denominator. How many parts in blue? 2. So let's say this one here and this one here. Can be any parts. 2/4. Now, I'm going to ask Lakau how to demonstrate an equivalent fraction of 2/4. How about this time, if we don't have 4 parts, but we have, how many parts, guys? 8. So Lakau, can you demonstrate an equivalent fraction of 2/4 with the denominator 8? How many parts? 1, 2, 3, 4. Excellent. And then you can write numerator 4. What we can do, guys, you can think of this like eating a pizza. This pizza has 4 parts. 2 have been eaten. This pizza has 8 parts. 4 have been eaten, but they're actually the same amount. So altogether, 2/4, 4/8. Equivalent fractions. Equivalent fractions. Lakau, that was excellent. High five and a big round of applause for Lakau, please, guys. Time for our next student, so I would like to invite Pat. Come and join me at the front of class, please, Pat. And it's time for Pat to choose his flashcard and show it to his friends. What do we have? 4/8 this time, like the fraction that Lakau just drawn. 4. So 4 parts. How many parts need to be in blue, guys? 4. 1, 2, 3, 4. So we've got 4/8 equals. Now, if I draw another circle and divide it into 2 parts, Pat, can you tell me how much of our circle needs to be divided into blue? What do we think, guys? One part, yes. So we can draw one part, Pat. Yes. Excellent. So how many parts do we have? 2. We've got 2 parts, so we can write 2 for the denominator. And then our line and number of parts in blue, which is 1. You can see 1/2, because 1 is half of 2. And in this fraction, it's also 1/2. 4 is half of 8. So altogether, 4 over 8, 1 over 2, equivalent fractions. Pat, that was very good. High five and a big round of applause for Pat, please, guys. So let's do one more together before we move on. But first of all, I'll clean the board. And now I would like to invite Dan. Come and join me at the front of class, please, Dan. And choose your flashcard. 8 over 16. Wow, okay. So guys, how many parts to this circle? 16. 2, 4, 6, 8, 14, 16. Let's count to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 16 is our denominator. And how many colours do we need in blue? 8. 1, 2, 3, 4, 5, 6, 7, 8. Eight over 16. Well, how about if I ask Dan to tell me an equivalent fraction using 2, 4, 6, 8. How many? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down. Can you show me the equivalent fraction of 8 over 16 with the denominator 10? Over to you, and I'll take your flashcard. So first of all, we can write denominator 10. Okay, so how many parts will Dan need to colour in blue? 5, correct. Well done, guys. Excellent, you can do it quickly because 3, 4, 5. See, once again, they represent the same amount of the circle, 1/2, because 8 is half of 16. 5 is half of 10. So we can say, guys, ready? 8 over 16, 5 over 10. Equivalent fractions. Dan, that was brilliant. High five and a big round of applause for Dan, please, guys. And now it's time for our worksheet part of the lesson. So teachers, make sure every student in your class gets their own worksheet. And what we've got today is we've got 4 questions. Each question has a fraction on it. What we're asking our students to do is demonstrate their understanding by designing and colouring an equivalent fraction in the circle that's provided. So remember guys, we're not drawing the same fraction, you need to draw an equivalent fraction, which is the same amount in a different fraction. But what's the first thing we need to do guys? Names on top. And give our students around 12 to 15 minutes for this activity and help them with anything they need. So Ned, this one's for you. You're welcome, Pat, for you. You're welcome, Nadia. You're welcome, Chu, there's yours. Down for you. You're welcome, Prel, for you. Bangpon for you. And Lakau. So guys, names on top first, and then have a go at designing your own equivalent fractions. Now, for example, question 1, what's the fraction that's given? 1 over 2. Okay, so we've got 1 over 2. 2 parts, 1 in blue. Now, you're not asked to draw that one. Think of an equivalent fraction that's the same as 1 over 2. For example, we could do 4 parts. Now, how many parts would we need to colour for the equivalent? 2, correct. You see, we could do 2 over 4. This is the same amount, so it's an equivalent fraction. Or, you don't have to do 2 over 4, guys. You could do, how about, how many parts now? 6. So you could do 1, 2, 3. 3 over 6. They're all your options because they're all equivalent fractions. Same amount represented in a different fraction. So Pangpon, not the same. Pangpon, not the same. You need to do equivalence. So 1 over 2, you need to demonstrate another fraction with the same amount, like 2 over 4 or 3 over 6. One over 2 is already done, so you need to demonstrate your understanding of equivalence. 1 over 2 is half, so you could do 2 over 4, equivalent half. 3 over 6, equivalent half. Okay, so Pakbong, you need to do a different fraction. 1 over 2 we have already, so you need to do an equivalent fraction. Not the same fraction, an equivalent fraction. Like 2 over 4 would work fine. Or 5 over 10. Excellent down. You see, 2 over 4 is equivalent to 1 over 2. And then 8 over 16. So what's half of 8? 4. So we can do 4 over 8 is the same as 8 over 16. That was right. You had 8 parts. 8 parts and then 4 in blue is correct. So remember guys, not the same as the question, equivalent. And today, in today's lesson, we're concentrating on halves. Welcome back to class. We hope your students enjoyed the worksheet activity and managed to show their understanding by demonstrating the equivalent fractions of each of those given in the question. Remember, we're not looking for the same fraction, we're looking for the equivalent, which means same amount in a different fraction. And in today's lesson, we've been concentrating on halves. you'll notice every answer works out to half the circle. And that's all we've got time for today. So we hope you've enjoyed the lesson and now understand a bit more about equivalent fractions, which means same amount but in a different number. And we'll see you again soon for the next lesson. So can we turn to wave and say goodbye, guys? Goodbye. Bye-bye. See you again soon.